Hello everyone and welcome back. This is our second video in our logic series and we're going to cover some more logical connectives. Let's begin with the first logical connective that we're going to talk about today called the implication. So the implication, and it's read P implies Q. So this is P implies Q or if P then Q. It's the statement which asserts that if P is true, then Q is also true. So if P is true, then Q is also true. That's what it means for P implies Q to be true. So another thing is that by convention, we agree that if P is false in this conditional or in this implication, if P is false, we say that P implies Q is actually true. And the easiest way to see this is with an example. So, or the easiest way to see why we choose this convention is with this example below. So let's look at this example. We have the statement, all cell phones in the room are turned off. Now, another way of saying this is that if there is a cell phone in the room, then it is turned off. So if it's a cell phone in the room, it's off. That's the way of saying it as an if-then statement. But what we want to consider is consider the case when P is false. So P in this case was if there is a cell phone in the room, right? If there is a cell phone in the room is false. So that would mean there are no cell phones in the room. In this case, it would still be correct to say all cell phones in the room are turned off because there are no cell phones in the room. It's a little bit confusing, but essentially it's not so much the case that we can deduce much about these implications, but another thing to take into consideration is that you can have implications that are true where there's actually no causal relationship between the things. So I could just state, like, just as a side example, if I'm 25, then, so I'm coming up with something that's true first, and then I'm going to come up with something else that's true that's totally unrelated, right? So if I'm 25, then the moon is white. Okay, so if I'm 25, then the moon is white. That's actually a true implication. I'm 25, that's true. The moon is white, that's true. But it does not mean that there is any causal relationship between P and Q. So the use of the word implies in logic is actually much more broad than the use of the word implies in a colloquial sense in everyday language. So next we'll talk about the biconditional or the double implication. So the biconditional or the double implication is a lot like the implication, except it goes both ways. So really it's if P then Q and if Q then P. So another way of saying it is that the biconditional or double implication, P if and only if Q, is the statement which asserts that P and Q have the same truth value. Later we'll see that if two statements have the same truth value, then they'll have the same truth table column. They're logically equivalent. We'll get into truth tables in the next video, but for this video we'll just see another example. So this is an example of a biconditional that almost seems a little bit strange. So all dogs are mammals is one statement. It's true. If an animal is a dog, then it's certainly a mammal. We know that it's a definition that we know that, right? We know that all dogs are mammals by definition because mammals include dogs and all kinds of other animals, right? But anyway, so we want to examine all dogs are mammal, and we want to examine the other statement. If the animal is not a mammal, then it is not a dog. These two are logically equivalent. And the way that I came up with this second statement is what I did is I used what's called the contrapositive. And we're going to get into that in a later video. I know it's not quite right for me to introduce that without formally introducing what the contrapositive is. But the second statement is the contrapositive of the first statement. All the contrapositive is it essentially is that it takes the converse. So it's basically you flip P and Q around. So maybe I'll write this in red. So if you have P implies Q, this, in other words, is logically equivalent. So logically equivalent to not Q implies not P. Or in other words, P implies Q is logically equivalent to the negation of Q implying the negation of P. So whenever this statement is true, this statement's also true as well. These are logically equivalent statements. Okay, so they in other words, they have the same truth value. So I wanted to introduce the implication and the double implication in this video. In the next video, I'm going to get into some truth tables, and they'll give us a better picture of what this all means. So we'll see you guys in the next video, and have a great day.